situated. Okay, so today we're going to combine the last couple of days. Okay, yesterday we did adding and subtracting. Friday we did multiplication. Okay, so today we're going to combine them with the two ways that we can combine multiplication with adding and subtracting. That's the distributive property and the double distributive property. Okay? So if I'm dealing with the distributive property, what I am going to do then is I'm going to take this whole outside, and it could be a number, it could be a radical, it could be a variable, it could be some combination thereof. Okay? And I'm going to distribute that into both spots or all of the spots inside the parentheses. No different than if this were like 3 times the quantity x plus 2. Okay, you distribute the 3 in. Now we're just distributing the 2 square roots of 5 in. Okay? So then this becomes 2 square roots of 5 times the square root of 6 plus 2 square roots of 5 times 2. And now you've got to simplify. Well, what's 2 times the square root of 5 times the square root of 6? 2 times the square root of 5 times the square root of 6. 2 times the square root of 30? Yes. 2 times the square root of 30. 2 times the square root of 5 times 2. No. 4 times the square root of 5. Because they're both outside. The 2's are both outside. Okay? Alright? Now, you have to ask yourself, can I simplify any more? So, can I take the square root of 30 and simplify it? Can I take the square root of 5 and simplify that? So, my question to you is this. Can either of those be simplified? Either of those be simplified? Okay, what can be simplified?
The first one can be simplified by its root.
What do you mean?
It's the thing that's above the
I have no idea what you're talking about.
It'd be 1.
It'd be what?
It can be simplified by like.
The square root of 30 is not 15, just so you know.
Oh, I know. Like there's 2 right here.
Yes?
So it can be simplified by that.
Again, the square root of 30 is not 15.
No, but I'm not saying that.
Okay. To be honest with you, Ben, I don't know what you're saying. So, you know what I mean?
You can like prime factor it?
What?
Do you mean like prime factor it?
I don't know.
Like 2 and 15 and 35. But then you
Are any of those perfect squares? So square root of 30 cannot be factored, correct? Okay. Can the square root of 5 be factored?
You can put it down. What?
But you just have to leave it
I
out.
was just saying you could like simplify the square.
I'm telling you, no. You can't be factored.
I'm not trying to factor.
I don't want it. Well, because then we're just going to be stuck in an endless cycle. We're going to go back up 1. You know what I mean?
Not if you multiply the square root of 5 times the square root of 5 and get 5.
But then what's the only number that I can multiply by? I can only multiply by 1. Otherwise, I change the problem. You know what I mean? You know what I mean?
Yeah.
Yeah. So I can't do that.
Okay.
Yep. Nope. So Neither of those can be simplified. Okay? What about the next one, number 10? What do we do on that one? This one would kind of look like,
You gotta distribute like. You gotta distribute like x to x and then x to the 3 and then 2x and then 2 to the 3.
so we got double distribute, right? So in this particular one, we would have to do the 2 would have to go into the 3, and the 2 would have to go into the square root of 5, right? So that would be 6 plus 2 square roots of 5. Agree? Then what?
Distribute the.
Got to distribute the square root of 5 then, right? Okay. So then that would be plus 3 square root of 5 plus square root of 5 times the square root of 5. What is going on here? Hold on. Craziness. Why is it not? Whoa. Whoa. Major things going on here. There. No idea what's going on here, just so you know. Computer's acting a little funky. There we go. Okay, so now what can we do?
Just add together.
What can we do, Jacob? I don't know, you tell me. You were the one having the side conversation. So what can we do?
You could combine 2 times the square root of 5 plus 3 square root of 5.
Okay, what would those combine to be?
5 times the square root of 5.
So these two combine to be 5 square roots of 5. What else?
You can multiply the square root of 5 times the square root of 5 to get the square root of 25.
Which is?
5.
So this one becomes 5.
Now can you bring that together with the 6?
Because they're both just numbers. Okay, so what would that become then? 11. So my answer here is 11 plus 5 square roots of 5. Okay? You do numbers 11 and 12 on your own. So that would become then negative 5 times the square root of 10 times the square root of 3 plus the square root of 6 times the square root of 3. Right? So this would become the square root of 18 which is the square root of 9 times the square root of 2. So this one would become negative 5 times the square root of 30 plus 3 square roots of 2. Yes? Number 12 then is really the square root of 7x plus 3 times the square root of 7x plus 3. So we get that one and that one. So that gives me the square root of 7x times the square root of 7x plus 3 times the square root of 7x. Then I got to distribute in the 3. That's going to be plus 3 times the square root of 7x plus 9. These two combine to just be 7x. So we get, and then these two combine to be 6 times the square root of 7x. So we get here 7x plus 6 times the square root of 7x plus 9. Now if you wanted to write that as 7x plus 9 plus 6 times the square root of 7x, that would be fine. Or if you wanted to write it as 9 plus 7x plus 6 times the square root of 7x, that would be fine. Okay. Or if you wanted to write it as 6 times the square root of 7x plus 7x plus 9, or 6 times the square root of 7x plus 9 plus 7x, all of those are the same thing. Okay? Try those two, 13 and 14. So these two make 3. These two make 0. So we get 49 minus 0 minus 3, which is, I get 46. Kind of cool that the radicals all went away. Over here, we get 16 plus 4 times the square root of 5, and minus 4 square roots of 5 minus square root of 5 times the square root of 5. These two make 5. These two make 0. So that gives me 16 plus 0 minus 5, which is 11. Remember what we called those pairs of numbers? No, it's a C word. Anybody remember? We saw them last when we were dealing with imaginary numbers. No, close though. What did you say? Sounded like you said conjugate.
No.
Oh. What did you say?
I'm pretty sure it's wrong.
Oh, okay. Because it sounded like conjugate. What do we call those? Conjugates! Yeah, we call them conjugates. Okay? Conjugates made the imaginary part go away. Conjugates make the radicals go away. Okay? And we'll use more of those tomorrow. Okay? So the last of the operations that we have to do is division. We did multiplication last Friday. We did adding and subtracting yesterday. Today we need to do division. Okay? So I will give you the property first because the property can be used in either direction. Okay? So the property is if I have the square root of A divided by B. So I got the square root of a fraction. What that is equal to is the square root of A divided by the square root of B. So sometimes it might be easier to use it as in one fraction in the radical. Sometimes it might be easier to use it as a radical of the numerator and a radical of the denominator. Top and bottom. Okay? So, for instance, here we could say the square root of 36 divided by the square root of 4 is, the square root of 36 is 6. The square root of 4 is 2. And so then that gives me 6 divided by 2 is 3. Okay? Or we could say then that the square root of 36 divided by 4 is the square root of 9, which is 3. Okay? Now, there's one condition with dividing by radicals. Okay? There's one thing. Now, in some religions, this week is considered Holy Week because Easter's coming up on Sunday. Okay? So, in honor of some religions' Holy Week, we shall make a mathematical commandment. Okay? Because back when I was your age, and even before then, we always sat around, the family always sat around, usually Easter weekend, usually I think it's Saturday night of Easter weekend, and they played the Ten Commandments on TV. The old Charlton Heston movie where he's Moses and all that fun stuff. Okay? So our commandment is this. Ready? Thou shalt, only because I really like the word shalt, not have any radicals in thy basement. What does that mean? So no radicals in your denominator. Okay? It's what we call rationalizing your denominator. Okay? Just like when we were dealing with imaginary numbers, we said no imaginary numbers in your denominator, no radicals in your denominator. Okay? Now, with that condition comes a reminder. You can only multiply by 1. Because if we multiply by anything other than 1, we're changing the problem. And we don't want to change the problem, we just want to simplify the problem. Okay? So we can only multiply by 1. Okay? Now, 1 comes in many different forms. Okay? Just so you know. And we'll show you that here momentarily. Okay? So, let's look here at the square root of 27 divided by the square root of 3. Now, there's a couple of different ways that we could do that. Okay? We could do the square root of 9 is 3. So one way that we could do that is we could make this be 3 times the square root of 3 over the square root of 3, right? Because the square root of 27 is 3 times the square root of 3. And then what can we do? What can we do with that fraction? Cancel what?
The square root of 3.
Square root of 3 divided by the square root of 3 is 1, right? So what are we left with? 3. Okay, that's one way of doing it. That worked out, that we could simplify the numerator, and then that canceled out. Another way that we could do it is, well, we could apply that this could be then the square root of 27 divided by 3. Right? What's 27 divided by 3?
9.
It's 9. And what's the square root of 9?
3.
Another way we could do it is we could say, well, this is the square root of 27 divided by the square root of 3, and we could multiply the numerator by the square root of 3 and the denominator by the square root of 3. What's that red fraction equal to?
1.
That red fraction is equal to 1. So I can do that. I can multiply by 1. I'm not changing the value at all. So then this would become the square root of 81 divided by the square root of 9. What's the square root of 81? 9. What's the square root of 9? 3. And 9 divided by 3 is
3 over 1, which is
3. So there's a couple of different ways to do this problem. Okay? Number 2. Which method, 1, 2, or 3, do you think would be the easiest? Claire? 2, right? Because we could make this become the square root of 81 over the square root of x to the 6th. What's the square root of 81?
9.
9. What's the square root of x to the 6th? X cubed. Is there any radicals in the denominator? No. Okay. What I'd like you to do now is I'd like you to do numbers 3, 4, and 5. So I would probably rewrite this one as the square root of 64x to the 5th over the square root of y to the 6th. Because then that would become the square root of 64, the square root of x to the 4th, and the square root of x all over y cubed. So my final answer here then would be 8x squared times the square root of x all over y cubed. Yes? Okay. Down here, I would simplify first. So this would be the cube root of 27 times the cube root of 2. Because 27 times 2 is 54. This one would be the cube root of 8 over the cube root of 2. What can I now do?
Cancel out.
Cube root of 2's both cancel each other out. Okay. What's the cube root of 27? 3. What's the cube root of 8?
2.
2. So my answer here is 3/2. Over here, I would make this be the square root of 5, the square root of a to the 4th, the square root of b to the 6th, and the square root of b, and the square root of c squared, all over the square root of b squared and the square root of b. Right? So this becomes the square root of 5 a squared b cubed the square root of b and c, all over b times the square root of b.
Why is it the
Didn't
square
you
root of c?
cancel out the two?
Why is it the square root of c?
It's the square root of c squared.
C. Just wondering.
The square root of c squared, which is just c.
Isn't it under the root though?
No.
Oh.
Square root of c squared is just c. Okay?
Did you cancel out the square root of b? Or
Now I can cancel the square root of b's out. Yep. Can I cancel anything else out? One of the b's from the bottom and one of the b's from the top, leaving me with b squared up there. So outside my radical, I have a squared, b squared, and c times the square root of 5 all over 1, so it's just that.
Any order that doesn't fit.
Preferably alphabetical.
That can't put the square root of 5 first.
I would put your radicals last whenever possible, okay? Because then your tendency to extend that radical over everything else, yeah. Okay? So, you are going to be simplifying radicals, and they're going to look a little different, okay? So, let's get some conditions that you need to. First condition is no radicals in the denominator. Whoa, whoa, whoa. I gotta rewrite all of that. See, because there it goes again. I love the Promethean board. No rad denominators. Okay, so no radical denominators. Okay, second thing, no perfect factors inside. What I mean by that is no like square roots of 12. Okay? Because the square root of 12 has 4 inside of it yet, right? And the square root of 4 is 2. Okay? So no perfect. So you got to factor, you got to make sure that they're all the way simplified. Okay? And then the last thing is we're going to assume that the variables are positive. Because then that avoids that whole I part. Okay? That we have to not worry about. Okay? Alright? So, let's try number 6 here now. Okay? Square root of 3 divided by 2. Well, 3 divided by 2 is 1.5, so that can't be simplified, right? So this is going to be the square root of 3 divided by the square root of 2. Have I violated any of my conditions? I got a radical downstairs in my basement, so that's bad. So I got to get rid of it. So what am I going to have to multiply my basement by to get rid of it? No. Just the basement. What am I going to multiply by? You said square root of 2, right? But I can multiply my whole fraction by 1, right? So if I multiply the basement by the square root of 2 to get rid of the radical down there, I'm going to have to multiply the top by the same thing. So that's my fraction. My fraction is the square root of 2 over the square root of 2, which is 1. Okay? So on top, what do we get? Square root of 6. On the bottom, what do we get?
Square root of 4.
Which is
2.
2. Okay? Now, I will tell you this. You are going to see this, and you're going to want to say, that's the square root of 3. Because what are you going to want to do? You're going to want to divide the 6 by the 2, right? But can we?
No.
The 6 is inside, right? And the 2 is outside. Okay? So they're not the same. So I can't just divide them. Okay? They both have to be inside if I want to divide them, or they both have to be outside. So that is where we stop. Okay? You do 7 and 8. I'm going to get all crazy. I'm going to do number 8 first. Okay? So this becomes the square root of x over the square root of 3. So then I multiply both the top by the square root of 3 and the bottom by the square root of 3. So then this becomes the square root of 3x divided by 3. Now, the reason I did that is because I want to do number 7 in 2 ways. Okay? The first way that I want to do that is I want to say, well, this is the square root of 5 over the square root of 8. And I'm guessing that 98.44% of the people in the room then multiplied the top by the square root of 8 and the bottom by the square root of 8. Okay? And that got you the square root of 40 over 8. Yes? And then you said the square root of 40 is 2 times the square root of 10 over 8, which is the square root of 10 over 4. Yes? Now, there's a couple of other ways to do that problem. Okay? One way is you could simplify the square root of 5 over the square root of 8 first. And so you could make that be the square root of 5 over 2 square roots of 2. And then what would you have to multiply by? Square root of 2 over the square root of 2, right? Which would give you on top the square root of 10. On the bottom, it would give you 2 times the square root of 4. Square root of 4 is 2. 2 times 2 is 4. Okay? My preferred method, I will do in the purple, right, is you've got the square root of 5 over the square root of 8, right? I'm going to multiply by the square root of 2 over the square root of 2. Now, why did I choose that?
Because that's 1.
Well, that's 1, yes. But what's the square root of 8 times the square root of 2?
Square root of 16.
Which is
4.
4. Okay? So this becomes the square root of 10 over 4 right away. Okay? Because the next perfect square that 8 goes into is 16. Alright? Try those 6. Give you 5 minutes to work on it. I'm going to start. You can keep working. Square root of x over the square root of x gives me the square root of 5x over x. 5 over the square root of 5 gives me 10 square roots of 5 over 5, which then gives me 2 square roots of 5. Over here, this would give me the square root of 8 would be 2 square roots of 2. The square root of 100 is 10. So that's going to give me the square root of 2 over 5. I'm going to save 12 for last. Square root of 3x over square root of 3x gives me 6 times the square root of 6x over 3x. So then that's going to be 2 square roots of 6x over x. Okay. All right. Let's deal with 12 first, 14 last. Okay. 12, I'm dealing with cube roots, right? So now I've got to look for perfect cubes that they go into. So my options here are, I could take this and I could go the cube root of 27 over the cube root of 4, and I would have to multiply that by the cube root of 16 over the cube root of 16. Can't just do the cube root of 4. Because the cube root of 4 times the cube root of 4 is the cube root of 16, and 16 is not a perfect cube. Okay? But the cube root of 64, because 4 times 16 is. Okay? So then this would become 3 times the cube root of 8 times the cube root of 2 all over the cube root of 64. This one becomes 4. This one becomes 2. So we get 6 times the cube root of 2 all over 4, or 3 times the cube root of 2 over 2. Okay. Now, an alternative to that particular problem is, instead of multiplying by the cube root of 16 or the cube root of 16, does 4 go into a perfect cube? What does it go into? Other than 64. What's another perfect cube that 4 goes into? 8, right? Okay. So I could take this as the cube root of 27 over the cube root of 4 and multiply that by the cube root of 2 over the cube root of 2. So on top then, I got 3 times the cube root of 2 all over the cube root of 8, which is 3 cube roots of 2 over 2. Okay. Got to kind of use your math logic. Got to think about what we want to get to. Okay. Now, on this one, okay, I would break this one up as the square root of 5 times the square root of 3 over 5 times the square root of 5 times the square root of 4. Right? Okay? Did I do any funky math there?
No.
No?
Just cancel the 5s.
Because now my square roots of 5s cancel each other out.
And you multiply that
And what's the square root of 4?
by 2.
That's 2. So that leaves me with the square root of 3 on top and 10 on the bottom. Okay? Your green sheet that I just gave you is the homework for this section. You can't do all of it yet. You need to have class tomorrow yet before you can do it all. So it will be due on the day of your test, next week, Thursday. Okay? Have a good day.